Hello, this is Mr. C. Welcome to a video on the rectangular coordinate system. The rectangular coordinate system you can think of as graphing. As you can see on this coordinate grid here, we have the x-axis or the x number line going left and right, the y-axis or the y number line going up and down in a vertical fashion. So when we graph a point for us will be located with something we call with an ordered pair. Ordered meaning alphabetical order. So we'll first put the x and then the y in that fashion, x coming before y. And if you change the variables on the axis, we'll normally just keep it whatever the variable is on the left to right, horizontal, and then the vertical. All right, so if I were to put a point on this graph, like I'll just place one right here. Notice that this dot that I put, it has both a location on the x number line. Like you can think about it as like, oh, okay, it comes down to 3. All right. So it's over 3 spaces. And it tracks to the 1 on the y-axis. So we would call that 3, 1. You can sometimes give a point a letter name. You don't have to. Like this could be point A. You could say A is equal to the ordered pair 3, 1. You should also be able to do this sort of backwards. Like if I gave you the ordered pair first, like let's say I said -5, -2, you should be able to find that on the graph. So you would do -5 on the x-axis. That would be back here, right? On the left-hand side, there's where your -5 is. And -2 on the y-axis here. And where those meet is this location right here. So that's your point right there. If we call that point B, it could be point B. Okay, now what you can do is take a combination of these points and make pictures or make a graph, a more complex graph. The most common graph that you would start with in algebra class would be a line. A line is just an infinite amount of points in a straight line. That's kind of redundant. I realize that because I'm saying line in the definition. But an infinite collection, infinite, I'm going to put the word infinite points in a straight line, make up a line. Okay, so often what we have with these is we have some sort of equation, give you an equation, and I'll just start off with something fairly manageable. Let's say that the y values are always equal to the x values plus 2 more. So what I recommend, and what many of you have probably done before, is to make a table of values, x and y, so that you can track how these work together. Now, you're actually able to just pick values for either x or y, but typically we'll pick a value for x. So for example, if I was to pick 0 for x, I would think of, okay, if x is 0 and y is always 2 more, I would just do 0 plus 2 and get 2. If x is 1, 1 plus 2 is 3. If x is 2, 2 plus 2 is 4, and so on. If I put in 3, I would get 5. All of these will be points or ordered pairs on the graph. You can think of this one as point 0, 2. That would be there on the graph. You can think of this one as 1, 3, and that would be here on the graph, and then 2, 4, and 3, 5, and you're going to notice this falls on a straight line. What you'll want to do at the end is connect the dots infinitely in each direction. You'll do infinite by putting an arrow at each end, all right? That will denote that it goes forever. And what it's saying is that this line is made up of an infinite amount of points, even points that are decimal and fraction values that we didn't do. For example, if x was 1.23, I could take 1.23 and add 2 more. It would just be 3.23. And that dot lives somewhere on this graph, probably about right in here on the graph. You can see that that would be about where it lives. So that's how you'll make up your basic graph, is just by plugging in points. When it gets a little more complex, you do have more work. For example, if y is equal to -1/2 x plus 5, now you have a little more work. What I would recommend when you have a fraction is try to pick values that work well with that fraction. 0 always works well because 0 times negative, well, actually times anything is 0. So when we plug in 0 for x, we'll just get 5 because that first part is 0. So that's easy to start off with. Now, you could choose 1 and 2 and 3 and 4 as I did from there in the previous example, but I'm going to skip 1 and I'm going to go to 2. You'll see why here in just a second. When you plug in 2, notice that the 2 cancels with this 2, and you're really just left with -1 plus 5, and that gives me 4. Oh, okay, I got a whole number. And so then if I skip to 4, something similar will happen. If I plug in 4, 2 goes into 4 twice, and I'm left with -1 times 2, -2 plus 5, and that's 3. Now, you can always make sure that as you plot these points, let's plot these two that I did. Let's plot 2, 4. Over 2 up 4 is here, and 4, 3 would be here, that those should be on a straight line, and they appear to be so. Once you find the pattern, you can go, oh, it's kind of like down 1 over 2. I can just follow this pattern out either direction to make my line as straight as possible. And if you use a ruler, it's better. I'm not using a ruler in this case. And that's a little bit how to use the coordinate grid system.